Hey everyone, Ben here. Welcome to another episode of the Stellar Work podcast. This is the second recording with Tom Soderstrom, who had been CTO at NASA Jet Propulsion Laboratory. Tom shares his insights about work and life at NASA JPL, as well as how to bring governmental organizations up to speed. Also, we're tackling the differences between commercial and governmental org and tech transformations. So without further ado, let's start this. Hello, Tom. Welcome back on the podcast.
Thank you very much, Ben. It's a pleasure to be back.
It's a pleasure having you. Last time we talked a bunch about AI and the future of work, and we got a couple of requests, and people were asking me like, how can you interview Tom and not ask him about how is work and life at NASA? I want to hear more about building rockets and spaceships, but you skipped all of that for the cheap trick on the AI topic where everyone's riding the hype train and skipped all of those interesting questions. So here we are on a second episode with Tom. I'm really happy that you came back. And yeah, so now this one is going to be about building spacecrafts and rockets.
Okay, good. And so we'll talk a lot about who builds spacecraft and rockets. They
Mm-hmm.
don't build themselves yet. So we'll talk about people and the experience and all that. No, thanks for asking. And guilty as charged. I guess we didn't talk much about that last time.
No,
So
we skipped it completely, and people were asking me, and the moment I saw those messages, I was like, "You're right. You're absolutely right. We missed an opportunity here."
but you know
So,
what?
yeah.
It was like working at NASA because you start talking about a topic and it kind of riffs off to other topics and eventually it leads back. All those amazing ideas that NASA came up with, it's never one person that said we should do this, or you go in and say, "Here's the goal today. We're going to figure out how to land on Mars." It it riffs and it moves back and forth, and that's really the magic. It's about those creative ideas just going in different directions. So the goal is the goal, but the way you get there is very flexible,
Um,
just like our podcast was.
I'm really tempted to jump right in because you said there is not like a single person that decides like where to go, left or right. And when I look at other space companies, especially the one Elon is running at the moment, as far as I can tell, or at least as far as some accounts, not sure if they're posting the truth or not, um, there is one leader at SpaceX that gives a direction, like where to go, which decision to take. They have like a 1,000-year goal or what they call it. And what you just mentioned is quite differently.
Mhm.
So can you elaborate a little bit on that?
Sure. It's just to be clear and to clarify what I said. The way NASA works is you have a science goal, and that science goal is determined by the scientific community, and it's usually called the decadal survey. And then you pick, here are all amazing things we could do. I'm not NASA anymore, but that NASA could do. And then you pick what you want to do. They're prioritized, get the whole community together and say, yep, these are the big ones. So these are typically pretty big expenses because they've never been done before. So now you know the questions you want to answer, how you get there and how you are able to answer those questions. That's the flexible part.
Okay, okay, got it. And also what I've taken from what you just said is that there is probably a big difference between a company that is striving to become profitable and to run a business and running NASA
Yeah, and
or
that was
doing research as you said.
and I think that's an important distinction. And I was asked that quite a lot when I worked at JPL, Jet Propulsion Laboratory. Is there a competition between private space and government space? Now I'm talking about that space out there. Uh, there is a great collaboration. I mean, very simply put, and this is my opinion now, is if there is business to be had, businesses should do it because they are good at it. There's a reason for it, it creates jobs, etc. If there is no business to be had, but it's an important thing for us to answer as humanity, a question, then the government should do it. And eventually establish a business. And if you think about going to orbiting the Earth and transporting to the Earth, to the space station, NASA was the only one that could do it for a while, then the Russian Space Agency and others. And now it's a business. It's exactly the right way. And then it gets privately funded. And then the governments move on to look for other things like, is there life in the universe? Is there life on Mars? Could an asteroid hit us one day and with very bad consequences? And how do we avoid it? There's no business there yet, but maybe there will be one day.
Since there's just the two of us here and we're having this easy chat, could you just leak a little bit? Like, is there life out there? Have you seen something?
They're talking to me here, the aliens. Just be quiet. No, I'm kidding. So basically, when so again, this is all my personal opinion. This is nothing else. I think there's life out there because if you look at something called Drake's equation, that's a fun one to look up. It talks about the probability of life out there. Uh, of course, there's a lot of variables, but when you think about the infinite, the astronomical size of space, it's almost unlikely that there wouldn't be. So what would it look like? I mean, nobody really knows, but there's a planet called, or a moon of Jupiter called Europa, and it has a big ice sheet around it, and it has lakes inside and underneath that ice sheet. And it hasn't been touched for something like 3.5 billion years. So is there life in those ice lakes? Uh, we'll find out because NASA has launched a spacecraft to Europa, and it's going to land, or not land, it's going to orbit Europa. It'll get there in about 2030, and then it'll look for a landing place. And maybe one day we'll have a lander that will come into the ice lakes and on the surface and maybe drill or melt itself into the ice lakes and look for life. Now I'm going to ask you, Ben, the interesting question. So now you are this spacecraft. You're automated, of course. There's no people on it. You're now in this ice lake. How do you know if there's life there?
So you would need to take probes, put them on a microscope,
Okay.
and check for signs of life.
Uh,
Like, it,
yeah.
um, I'm,
I'm
I'm,
putting you on the spot here. There is an answer.
I'm looking for the English word. Um,
Say it in German. AI will translate.
oh, I can like for metabolism. Is that correct?
So let me cut to the chase. We
Yeah.
actually thought and that's one of the really fun things to work at Jet Propulsion Laboratory where I was, which is a part of NASA. You have these discussions, and it's not you're just sitting and having a glass of beer and talking about it. It's actually work. So it's an amazingly fun place to work. So the answer, at least one answer, is if you look at all the particles that are likely in that water and you find they're drifting, but something is going upstream, it's drifting away
Mm-hmm.
from the others, it's
Mm-hmm.
probably self-propelled.
Mm-hmm.
So you could look at just do an AI algorithm that could sit on the sensor and see if something is moving against the stream. That's a very simple way of getting started. And we did that at JPL and found that you could actually do that in water. Of course, we looked at the water on Earth. So it's a fun thing to do. Uh, so that's how, is there life out there? It's probably microbes, but it's a great question.
It would be so cool if people would just go there and looking for microbes, and you would find like half a kilogram big fish.
Yeah. Yeah.
It's just
And and the
completely
fish
random.
the fish would eat the sensor.
I mean, that would be a hell of a story. I
Like
mean,
Jonah and the
and
whale.
NASA is researching and is looking at the most interesting stuff, and like a lot of the questions regarding the podcast was how do you really get a job at NASA? Because a lot of people dream of working at rockets, space, becoming an astronaut is one of the children's dreams. Like, but how is it in real life? Like, how do you enter such an interesting area?
Yeah. So I was lucky. I ended up coming in as a programmer and then programmed for a long time the Deep Space Network, and then ended up doing more, being involved in most projects, most missions. A mission is something that flies in NASA speak. And the fun then in those days, there really was only for people in the US, NASA. Today, there is all kinds of space companies. So it's never been easier to find a spot to work in the space industry now than it is now. And that's really exciting. Because in the end, when you look at NASA, people say you spend too much money on NASA. Where is that money spent? On Earth. It's spent on Earth on people who are building space. And it used to be that only the governments funded it. But now commercial space industry is actually going to outfund the governments. So, do you working at NASA is really cool, very fun people, and but you don't have to work at NASA to work in space. That's really the message. So for the people who are listening to this, hopefully somebody's listening to us, uh, you can work in the space industry much easier than you ever could before. Lots of data is there to be investigated, to be that is coming from space, but you don't even have to send a spacecraft to participate. And that's the exciting part. Of course, building and sending spacecraft is pretty cool. Uh, so there's all these satellite companies that are coming up now. Well, we can talk more about that if you want. Where is the market going? It's booming. It's booming in a good way.
I'm really curious how to see that. Like, we moved places and we now live in a more rural area. And I'm looking at different internet providers to get some satellite internet. And just thinking of like having that antenna on the house and looking up and you see those maybe Starlink, maybe whatever, small little dots in the sky that would form a line. That is just really cool. Really, really cool. But I would imagine that working at NASA is quite differently than working on like at a commercial like on a company that is really making a business case behind that. Because at NASA, I would assume it's more research heavy than business heavy regarding what you're working on, and probably as well as what the company is structured and how it feels working there.
At NASA, it's a longer time frame typically.
Hmm.
Things that have never been done before, and that's really if something has never been done before, how do you do it? Well, you can expect that you're going to fail a lot on the way there. So that's why it's so important to have here's where we're going. And the very first attempt is not necessarily going to work. So you have to be resilient. You have to understand that the world doesn't the world doesn't end because we failed the first one. You just keep learning and trying and learning and trying. Commercial space business does that today pretty darn well. They build in the fact that failure is part of the journey. And I think SpaceX in particular has done that well. They said, okay, it's not going to work the first time. Yes, this one blew up, but it's okay because that's part of the journey. And that's difficult for companies and governments to accept, but it's important. Something that's really difficult will not work the first time, but eventually it will if we keep trying.
Do you see a difference in governmental and commercial spacecraft where regarding the company culture? Because I'm thinking about if you run a commercial spacecraft business, you would have all the business incentives for people working there. But if you're more on the governmental side, you're probably not swimming in funding and hiring like the top engineers and competing with SpaceX or Apple or Google on the top engineers. So there must be something else that is motivating people to go there. And I know it sounds stupid to maybe ask the question because everyone would probably want to work at NASA, but I would assume that if you work at NASA, you're not like the head engineer designing the spacecraft. You're probably still like contributing on a way smaller scale.
It's I'm going to talk about that in a couple of ways. One is you're absolutely right. One of the things that was really fun and interesting at Jet Propulsion Laboratory is that you have a duty to say if you see something wrong, because the failure could be so expensive and so big. So there's a lot of debate, a lot of discussions, but it's for the good of the mission. It's for good of that end goal. Uh, so you're not criticized for criticizing. On the contrary, people say, okay, why do you think so? And it doesn't really matter that much where you are in the hierarchy. Everybody has a voice. That's one of the lessons that we learned from some of the things that didn't work the way they should have. We stopped, we didn't criticize as much as we should if we saw something wrong.
Is there a
Uh,
trick to get everyone to speak up? Because I think it would take some courage to speak up.
and that's the thing that we see now in any large enterprise. I'm going to generalize here, but not just space. If you have a company that has been successful, so they're around for a long time, so they grew large, you have silos, you have bureaucracy, and it becomes very difficult to criticize and change and move fast. And especially if you think about a startup says fail fast. That's part of it. No problem. An enterprise have a hard time doing that, including at companies like or enterprises like NASA, because failure is still a failure. It stays with you. So my recommendation here to anybody who's in an enterprise, don't say fail fast. Say experiment quickly. It's different words, kind of the same concept, but it doesn't have that connotation of I failed. No, I experimented and I'm expected to move forward. And we see commercial businesses doing that really well. Uh, this experiment quickly. Uh, there's here's homework for you, Ben. Uh, I was on a flight from Europe yesterday, actually. I'm in Los Angeles now. That's my home base. And I was flipping to see a movie, and I came up on a movie called Wild Space. And it's a documentary about this particular space industry that we're talking about. And I'm seeing all my old friends being the ones that started the company. It was so much fun. But it's a great view into this wonderfully growing space business and how hard it is and how it iterates and changes, but
It's
also how
called Wild
fun it is.
Wild Space, right?
Wild, wild space.
Yeah,
And
from
it was from
2024.
HBO. Yeah. And so it's very recent and exceptionally well done.
All right, put it on the list. It's on HBO.
Or if you happen to be flying a United Airlines flight, it's on there too.
Yeah, that might take some time.
Yeah. But for anybody who's listening in this and interested in space, it's a great take on how hard it is to build these rockets and build a business and how fast it's moving. And I think that's a microcosm of what we're seeing in the space industry. And the governments and we can talk more about that, but how government now, instead of doing it all, is collaborating very closely with commercial businesses, large and small.
So is that the way to speed up an enterprise or a governmental agency that is very tightly packed and intertwined in regulation, processes, tender offerings, and which is making things really slow? Is that the way to go to collaborate?
It is, it is. It's a collaborating in two ways. It's collaborating with, when you think about Amazon has this way called it working backwards. Have you heard of that?
No, I
Where
don't think so.
instead of saying, here's the technology, what can I do with it? You say, what's the customer looking for?
Hmm.
And how do you then build the technology that gets there? And there's a whole process behind it that we can talk about if you're interested. But there's even a book called Working Backwards. That's a great read. It explains the whole how Amazon works.
So many references here today.
But it's uh, so when you think about how to move faster, one of it is what's going to stop you. It's the regulations. It's the compliance. So working backwards with the compliance officers, whoever they are, whether it's cybersecurity or risk or somebody else, saying, what do you need for me to go live or launch my spacecraft, and work backwards there, as opposed to building it and then waiting and waiting and waiting and maybe never launching. And it sounds obvious, but it's not. People tend to avoid those discussions until they actually have to have them. And I'm recommending the opposite. Have them now. Have the discussion before you start. We did this at the Jet Propulsion Laboratory, and it worked quite well. When something called Amazon's GovCloud came out, we had those discussions ahead of time, and were able to go live very quickly. So that's one. The other one is then bringing new technologies and new people to experiment quickly. And so those two together, from opposite sides, but they work really, really well together.
Have you got an example for us from NASA or JPL where we could give a little bit more details
Yeah,
on?
let me give a couple.
Mhm.
Let's see. There's so many. Let's start with data. I mean, if there's one place to start today, it would be with data because there's so much of it. I heard an analogy, by the way, which is if you look at data, think about a highway of a car moving uh, one way and a car moving another, and that's data in the past. Every so often you see a car. Now it's 100-lane highway packed with cars, 1,000 of them, and that it's so much data. So how do you deal with data? We had this problem at JPL, and I wanted to see at the time, how can we deal with all this data that's going to come? It's too much for a human brain. Could we visualize it somehow? Could you see the data? So we did a startup inside JPL, and as one of the projects here, this new
Like
trend.
you founded a separate corporation out of
Um,
JPL.
uh, that was the advice from the experts: is you cannot do a startup inside an enterprise. But our point was not to do that. We wanted to bring in new technology to Jet Propulsion Laboratory. So we did a startup inside JPL in space, physical space that nobody else wanted, brought in a lot of interns uh, in specific areas. So data visualization was one. Then we did projects and we hired the best of those interns, who then brought in interns next year and hired the best of them. We had 8 technologies we were trying to advance because we did.
Trying to understand how that would go because
Yeah.
me thinking about it without having any knowledge whatsoever, I wasn't there, but I would assume that you would be in a room full of people with process knowledge on how things go at JPL, and you would say like, "Hey, so we encapsulate this one thing here. We run a bunch of projects, and they will have like no strings attached, no red tape, and they we just let them go."
Yeah,
Is
because
that how it went?
essentially, yes. Yes, because you have to look at what's the risk? And if you're looking at your internal data and by the way, that works on the cloud too. So it does not have to be on-prem. And this was actually in the cloud. You look at that data and you say, what can we find out from it? So I'll give you a very specific example. I'll give you two, actually, if that's okay, on data visualization, because it's still underappreciated. So when we started saying it, the scientists said, I don't need to visualize my data. I understand it. And then once we did visualize it, they would look at it and they would ask, why is that spike there? Nobody else would see that spike, but the scientists that understood the data would. But they never saw the spike until they saw it visualized. So I'll give you two examples. One was we wanted to see why were some spacecraft built faster and some slower? Uh, uh, and could we find out from the data? So we looked at the data and it's moving. And what's moving is there are signatures saying, yes, you passed this stage. and this stage, and this stage, and this stage. They are actually signed documents. So you can look at the signature dates. We took all the data and we visualized it moving across a timeline. And you could see that some moved really fast and some moved really slowly. So now that was a great one. Now you can dig into what's the cause. So it had two causes in the end. One was that there were too many people on the sign off list. And it sounds good, right? People should sign off. But what if you have to chase them down every single time? They're on jury duty, they're on vacation, and until you can start the next phase. So we reduced the number of signatories to be fewer. And by the way, that's how commercial businesses work today in space. The second one was they were physical signatures. So you had to chase them down. Changed that to email signatures. Digital signatures. And now every spacecraft could be built faster without changing the way we build spacecraft, just changing the process. And that came from visualizing the data. So that was amazing. Then everybody said, well, this makes sense. We should do data visualization.
How much faster did you end up?
Gosh, I don't know because there's so many spacecraft. But it was really about reducing the time when nothing happened between building. Or speeding up if there was an error. You could see that too. Because you could then go back and say, why did it take so long? Well, it had these errors that had to be fixed. So you accumulate the data. And now with AI that we talked about in the last podcast, you can pour over that data much faster and get insights.
So how long did it take in you at JPL figuring out where those waiting times are and rolling out the technology to speed it up?
Not long. Because once you have an absolute cause and effect,
Mm-hmm.
now instead of having to fight every bureaucracy there is in any company that, well, this is my domain and that's your domain, you see that if you just do these two things, you'll speed up the whole process. So to visualize the data with these interns now, remember, they were just experimenting, looking at data visualization. That was done in 2 weeks of just once they get access to the data to visualize it and show it and demo it. And then going through the process of changing to digital signatures and fewer people signing, that took longer, but much, much faster. It would never have been done had you not actually seen what could happen.
Mm-hmm.
Another data visualization was about cybersecurity. Could we see if people were trying to hack and steal data? And you could now visualize on a world map data going out in real time and to which countries. And it was once we dug into it, it was fairly straightforward to do. And then that actually helped us saying, okay, we need to beef up some cybersecurity processes here.
I would imagine that companies, JPL a company or an agency? What is it?
A JPL is what's called a federally funded research center
Ah,
of NASA,
okay.
which is an agency.
I would assume that NASA or JPL are probably getting attacked every day.
All of NASA is, and all of JPL. That's cybersecurity. For those who are listening now, is a great place to spend time on because every company across the world needs better cybersecurity always. And it's almost like a detective drama where you have to the offenders and the defenders are each going to get faster and better. But it all comes back to the data. How can you investigate the data and move quickly? So I think every single company across the world is going to be interested in space too, because if somebody could hack your uplink commands, then you're in trouble.
Hmm.
So we're seeing a lot of advancement on cybersecurity.
Really interested in finding those levers in companies and organizations in general that if you fix them, you could really speed things up. And I wonder, like, is there any technique that you would go for going back to that problem on identifying where to start? Because I could imagine that either at JPL or at NASA in general, there are like a million ways you could start doing this. But how do you get your first steps?
I think there's something called a tenet. Do you know what a tenet is? A tenet is, so if we look at Amazon, for instance, there
Hmm.
are leadership principles
Hmm.
that applies to every single business within Amazon, and there's lots of them. Then each area have their own tenets. And a tenet is kind of an agreement on here's how we work. And so for instance, one of my tenets in a group that I built in AWS was uh, the productivity over perfection. Because if you try to be perfect up front, you're going to argue too much to start. So be productive and iterate towards perfection. So that's a tenet that explains how we work. One of the tenets here is to build security in. Don't add it on. So what does that mean? It means that every step of building has security built in so that you don't have to, once you go live, have a bunch of cybersecurity verifications and checks that slow you down. Because if you do that, all of a sudden you're ready to go live, but you can't because somebody has to approve it. And if that takes a long time, those builders who built it might leave. And now when you finally go live and you find bugs, there's nobody there to fix it. So building it in at every step is overall how you do it.
How would you approach that? Would you bring cybersecurity people onto a team? Would you create more T-shaped profiles and everyone has to learn about cybersecurity? Or what is, do you get like sparring partners from a cybersecurity department? What is the best way to integrate all of those disciplines?
You actually mentioned two of them right away. The T-shape. So T-shape, for people who don't understand it, perhaps, is you're really an expert in one piece, but you have a broad knowledge of others. So the engineers would get an understanding of cybersecurity. The cybersecurity expert gets an understanding of the engineering and what we're trying to do going live. The T-shape is one. The cross-functional team is another. So include cybersecurity personnel in your project. And they may be what's called dotted line, uh, but they're part of the team. So if there is a cybersecurity issue to be discussed, then they are well aware of what the project is, and they can discuss with this overall cybersecurity team. We did this at JPL and it worked really well. So and it's not enough to have the department involved. It's got to be a person who's part of the team. So those are two. The third one,
Let me get back to the second one before we go to the third.
yeah,
Because I wonder that if I'm on a team as a cybersecurity specialist, which I'm not because I'm T-shaped, I get it, but I have to work on non-cybersecurity stuff as well.
yeah,
Or do I
that's
just
right.
wait and
No, no, you're part of it. But because your interest is cybersecurity, Ben, um, you're always looking at it. You're always looking for things that could go wrong. The other thing you're doing is you're infusing cybersecurity into the team as a whole. So a really important thing is to learn on the job. That's how we move faster in all industries, including space. Don't send people off to a class and they come back and now they don't have anything to work on. Instead, learn on the job. And having a cybersecurity person embedded in the team accomplishes both things. They're looking for risks and they're educating people and they become friends. We like to work with people we like who are part of the team. So I think that's really the cross-functional team is really key.
any tips on companies who are not already there when they want to build those cross-functional teams with the T-shaped team members, but at the moment they're having a culture where I'm working in my field, you're working in your field, and depending on the work that comes in, it's either for you or for me.
It's surprisingly common. I think this is a big area. You've identified a big area for companies to improve. And it's really, it's about just getting started. Uh, it could be as simple as saying, let's say we have a team of 5. I highly recommend small teams. Uh, saying, okay, Ben, you're on it. You're now going to be focusing on cybersecurity as well. And here's a relationship with a cybersecurity organization. So you'll attend their team meetings, etc. But you're really part of the team. So you came from the engineering side. Or you take a cybersecurity person and say, you're going to be part of this engineering team now, part-time, attend their team meetings and keep us up to breast what's coming. So at JPL, we did this thing called, we transformed at the time, information technology to be innovating together. So one is a noun, I'm going to protect my turf. The other one is an active verb, we're going to innovate together. And it worked really well. So it's just kind of expanding that to any organization, but especially cybersecurity. So
Okay.
it doesn't have to be a big project. It can be done piece by piece by piece.
But you have to accept that the person not working within their special field, like in the beginning when you start doing this, is probably not as fast, not as productive or efficient as another.
And that's okay. So that comes back to another question you asked. How do we get people to move faster? It's going to sound corny, but it's psychological safety.
Hmm.
It's to create an organization where it's okay to experiment quickly and not all the experiments pay out. And that comes from the top leadership. They have to create uh, saying that, okay, everything isn't going to work, but if we don't move fast, we're going to fail.
But also
And
accept the learning curve and yeah,
yeah,
the probably the performance that goes down as well, I would
well,
assume.
the performance actually
At
goes
least
up.
in the beginning.
The performance of that individual, if you come from a cybersecurity group and
Hmm.
you're joining an engineering team, of course, you're not going to have the engineering skills yet, but the overall speed of that project goes up because at the end, they don't have to wait as long for cybersecurity approval because it's built in all the
Hmm.
way through. And what is an approval? Well, it's passing some tests, but it's also somebody saying, yes, I'm comfortable. And if the cybersecurity team is involved the whole time, at the end, they will be comfortable. Now, the third one, you're ready to go into the third piece?
I am.
So the uh, it's to build in cybersecurity. How do you do that? Use these new AI tools of generative AI that we talked about last time. So Amazon, it's Amazon Q for developers. And now you can build in cybersecurity automatically every time you program because it's your policies, it's your data. And if somebody is violating it, it'll tell you right away saying, nope, you can't do this. Do it this way instead. And I've talked to many developers now, especially the young ones who are building it in. They use generative AI tools like Amazon Q for development. And it makes it faster and it makes it much safer. And cybersecurity is built in. So I'd say those are the 3. And it doesn't take a lot of money. That's the key.
I think it takes balls to try it if it's
Yeah.
not in your DNA, if it's not in your company culture, to really endure and but also like on one side train your staff in other disciplines, and on the other side like really get rid of that approval process, that cybersecurity approval process, because trusting that it's built in along the way.
Yeah. In the end, you will have to have that check mark, but it's going to get much easier and faster because it's more secure. And it's
If
really
it's
about
checked throughout
building
the
speed.
project.
Exactly. And also, that also means you're not going to have those huge leaks, data leaks or failures
Hmm.
throughout the building process because it's being checked the whole way through. Um, so I think in the end, for training and bringing in these skills and having the guts to do it, is to solve business problems all the way through. It's not a technology experiment. It's an experiment of solving that business problem. And then you get much less pushback from the different departments. Um, we overcame that by saying, whatever project we had at JPL, here is the mission of JPL and NASA. It this If departments are disagreeing, you cannot disagree about the overall goal. Is there life out there? Where is the universe going? Where did it come from? Etc. If you keep those top level goals in mind every single time, people will always do the right thing.
Right. Final question. Are you ready?
I am ready.
You're not in university yet, but you're looking for a university degree. You're looking for any sort of higher education that gives you a good boost into the career of working in the space industry. What would you advise young people to do in order to land a good job or build a career within the space industry?
That's a fantastic question. I'm not sure I'll have a fantastic answer, but uh, I just had this discussion with some people who hire thousands and thousands of people. Uh, and we discussed it specifically about generative AI, as it turns out. Is it cheating to use it? What will the future interviews look like? And we kind of decided that the future interviewer wouldn't say, I caught you using generative AI. They would say, okay, Ben, you're interviewing for this job. Tell me how you would use AI and generative AI and machine learning to advance our company. So how do you use this new tool? Because it's just a tool. Uh, and I think to me, it still should not be called AI. It should be called IA, intelligent assistance, because it's really about making the human go faster. So I'm drifting back to AI, but it is a way of making us work faster. And so if you are a young person in school, make sure you learn those tools and experiment hands-on with them. Uh, so that and then follow your passion. If your passion is cybersecurity, by all means, that's a great path. If your passion is to build rockets, that's a fantastic path. If your passion is data, oh, it's booming. And if your passion is Internet of Things, or tinkering with hardware and software, then that's the best of all worlds. Because I think the future engineers, the ones who can actually work hardware and software, are the ones that can go anywhere. And it's easier than it ever has been before, but it's hard enough to be challenging. So
Would
I would
you
say that's what I would recommend to students.
would you say it would make more sense to go into the research, or would you say would make more sense to go into the commercial side of things?
I actually think they're merging in many ways. I mean, research is, which I could talk about a lot, but it's more about publishing papers, and it's about doing things that nobody knows the answers to, uh, and which is super important. But you can do it faster than you ever could before, and so you're going to use those new tools and high performance computing on the cloud. You don't have to own a supercomputer anymore to kind of answer the questions. If you're building something, you need to do research to figure out how to build
Mm.
it. So they're moving closer. They are just if you're a researcher, you go very, very, very deep. If you're building something, you go deep enough to be able to use that. So uh, it's where your passion leads you if you're a student, and you don't know until you've tried many things. So don't be afraid of switching careers. Don't be afraid of trying something new. But you got to dive deep enough to know if it's really for you or not. The other thing I would recommend to students, my first job, guess how much I made? Zero, nothing. I couldn't find a job, so I went in and said, will you hire me if I work for free? And they did. So now I could build a resume. So for students, don't look at the money. Look at what you learn, how it advances your future. And internships are a great way to do that.
Especially in the early years when you're not
Yep.
having all of that responsibility and having to feed a family, pay off a house, or whatever it is.
And if you have an itch at all to do a startup, do it. It's an amazing learning experience to do. I've done several, and I still remember the passion of trying to do something new and fast. And if they work and they make you lots of money, that's great. If they don't work, it's still great because you learn all that working experience.
I'm still with my very first startup here, and I
Good.
can I can totally see what you're saying there. It's you learn so many different things, and you also you get comfortable becoming a T-shaped person, so to
Yeah.
say,
You don't have
because
a
you have to,
choice.
yeah, you have no choice. You have to dig into accounting to a certain level. You don't become an accountant, but you have to know how things go. You have to know how taxes work, but you also like all of those side things that are going on inside a startup that are not at the core of what the startup is doing, but you also have to do it as well.
And if you tie that back to the space industry,
Hmm.
there's now lots of startups working with NASA and other space agencies, even landing on the moon, like lunar orbit. And there are all these startups actually building spacecraft and or participating with others. So it's all about partnering. And how do you partner? On the internet, in the cloud, using data and using passionate people from all over the world. You don't even have to be in the same place anymore. It's pretty amazing.
Yeah, it is. Tom, thank you so much for jumping on the pod a second time. It was great talking to you.
Thank you. And speaking of not being in the same place, I hope Germany is good. I'm in Los Angeles, so
It's really good. It finally the sun came out, and I think winter is gone. It's gone. It's just sun and everything's in bloom. It's perfect.
although April can be tricky.
Uh, I think we crossed the chasm. We're
Good.
now off to a good summer season.
I love it. Thank you, Ben. It's been a pleasure.
Thank you. Likewise. Bye bye. Thanks for tuning into today's episode. It would be super cool if you could give us a like and follow on your favorite podcast player, or recommend this episode to someone who might like it as well. If you got someone in mind who would be an interesting guest on the pod, feel free to reach out at info@stellarwork.com or via LinkedIn. See you next time. Bye bye.